For you folks who remember control theory class, maybe not many of you, first day of class you learned that if you can measure and account for all the disturbances in a process, then you can control it without the process variable changing. So here's an example from industry, right? I'm working on a site that is plant scale wastewater treatment, water treatment. And so we're controlling the pH in a effluent tank. If you can measure pH on the incoming streams to the vessel, and you can measure the flow rate, then you can calculate, using your high school chemistry experience, all of the ions that you're dumping into that tank. For the different pH levels, 10 to the 14 minus X or 10 to the X gives you the concentration of what's going in, multiplied by the flow rate, you know the rate of what's going in. You can take the difference between those two, calculate how much acid or caustic you have to put into that tank in order to make up your disturbance. And so you can sit there flat line at pH 7 with everything coming in. Just remember that first day of control theory class where they said if you can measure it and account for it with a model and counteract that disturbance, then your PV doesn't change. It's when the PV actually changes that you get feedback control. And so do the feed forward stuff, PV doesn't change, nothing for the feedback control to do but mop up those other disturbances. That's the lesson of feed forward control.